Similar on the right, it's hoist up, hoist down, gantry left, gantry right, spreader retract, spreader extend. Well, you can read it as well as I can. So it's almost like playing a computer game with the two controls. And these controls are controlling a piece of equipment that weighs 1,200 tons. So it's quite incredible. Here's a slide that I have little understanding of. We've got automatic sway and skew control, and you can see the little drawing on the left-hand side, which indicates what it is, the container swinging around on the end of the cables. Charge couple device, camera and heated reflector, trolley, headlock. On the right-hand side, we've got a reflector and we've got a camera on the trolley platform that indicates movement. That then goes through an earth net, whatever an earth net is, into the cabin switch, and then a fiber optic, another earth net, PLC, another earth net, profile bus. Well, you can guess what all that means, but all it means is automation. So it can automate the sway. Ship profile scanning system. We have 2D and 3D LiDAR scanners. This gives a visual indication of the terrain over which the container has to maneuver, how the containers are stacked on the ship, so it avoids hitting the containers. So we have laser A and laser B, cabin control box, PLC. So how all that works, don't ask me. There are three things in this world I don't understand. The first is money, the second is women, and the third is electricity. So I have no control over what all this is about. But anyway, maybe some of you bright boys at university will have a better idea. Right, remote control, hardware and devices, chassis positioning system. If you look over on the right-hand side of the screen, you'll see these red boxes with X's on them. These are the containers on the trucks that are maneuvering beneath the key crane. So out to the right is the C, and the two legs on the two portals, two portal beams, those are the supports for the crane. So we've got traffic light displays on the portal beams, so the drivers can get some idea as to where they are they in the right position. We have a 3D scanner that scans for the truck and chassis positions. And on the left, you'll see a schematic indication of how that operates. We got two portal beams, one on the left portal, one on the right, and it scans to find out where the truck and the trailer is, so in order to put it in the right position to receive the container. Traffic light display for the drivers. It's just an example of the sort of displays that drivers will see. So top left is the 5 is lane 5, the driver is in lane 5. Move forward 99 centimeters. Move forward 55 centimeters. Lane 5, right position, you can stop, you're in the right place. Lane 5, I'm sorry about the English, it says chassis go away. It means, it's written by a Chinese sub-consultant, it means the chassis can leave the position. The next one is power on pattern, just telling you that the traffic light system is up and running. Lane 5, can't leading, it should read can't loading. In other words, there's some problem that they can't load the container. Down below, very similar, backwards 99, backwards 55. Chassis positioning system error if it's flashing red. So the driver knows that he's got a problem, he's not going to get any signals from the traffic lights. Lane 5, chassis positioning system idle. Chassis positioning system diagnosing, it's deciding where you want to go. And lane 5 chassis positioning system. It's calculating. It's not decided exactly where to put the truck. So those are typical sort of traffic light systems that we have. The remote control system, remote control network. There's 5 elements to this, and you'll find out how I know there's 5 elements, because if you look at the picture on the right, it says number 1 key cranes, number 2 fiber optic, number 3 fiber optic switch, number 4 EarthNet, and number 5 remote operating station. So the remote operating station is remote from the cranes, and the operators, as I say, if one crane becomes idle, you can, if there isn't an operator for the next crane, you can take over the next crane. No need to move around. Hardware includes the following, which make up the remote control quayside crane network from the quayside to the remote control center. The remote control center was that picture I showed you above the gate with all the windows in. That's where it is in Thailand, in Laemchabang. The key cranes connected via fiber optic switch, EarthNet. I've just been through those. So anyway, that's the basic system. One thing that you will need when you're designing a new container terminal is plenty of ducts. And however many ducts are in the design, always give yourself 100% redundancy, because for sure you'll need plenty of ducts to add in more cables. Here's a, I think this is a, hang on, yes, this is a video. And I understand there's no sound with this, but it just shows the guy operating the controls. He's looking at the screens in front of him. The red button in the yellow enclosure is the emergency stop button. And you see, it's very easy for the guy, easy to sit down, and nice environment, no safety clothing required. And there you go, he presses the button and now it's automatic after that. He's done his manual bit. So I hope you all saw that okay. Let's move on to the second one now, which is the rubber-tied gantry crane, RTGCs, from manual operation to remote control and automation. This diagram is a plan view of a typical container stacking area. The horizontal, or the vertical sort of lines that look like the bones on a fish, these are the stacking plinths that we have, the containers. The 40-foot containers generally go on the ends. The 20-foot containers generally go in the middle for safety reasons. The RTGCs don't have to gantry out too far into the lanes for the trucks. The red squares are the mini substations that we have. Now, the power supply from the main substation is 22 kVA, and then it's lowered down to 44 volts at these stations. And then we have conductor bars going from each side. And so we have one rubber-tied gantry crane on the north side, one on the south side. So we have 2 gantry cranes on the west end and 2 gantry cranes on the east end. So each substation can provide power for 4 gantry cranes. Now, one thing to watch out for is when they're operating at the far end, there is voltage loss and power loss. So you have to make sure that you have adequate power to give sufficient power to the key cranes whilst they're operating at full capacity at each end of the stacking areas. Otherwise, the trips will trip off and the key cranes will stop working. So that's the basic layout of the power control. This is a sample. This is the rubber-tied gantry crane wheel. And we have this device that connects to the power supply. There is a ramp, a metal ramp, which brings the connector up onto the conductor rails. We have two Diablo rollers which run on circular or tubular rails. And then we have the collector trolley with the connectors here pick up the power from the power supply. So that's the basic idea. Here's a side view. These are the connectors that pick up the power supply. These are the Diablo rollers. There's one down here, two up here. And this is how we bring the RTGCs onto the power supply. The RTGCs have small donkey engines providing a small diesel engine, so that when they have to go from one stacking area to the other, they lose the contactors. They can just maneuver across the access road under their own steam by a small diesel engine. Here's the conductor rails. At the top, we've got data transmission. So this is an optic fiber. This provides the information to the operator in the office. This is the positioning system with these markers on here. This is operated by a camera that can locate the position of the RTGC, the rubber-tired gantry crane, in order to pick up a particular container. And this is the conductor. These are the conductors. Here's the tubular runway system. There's the other one. And these are the two conductors. So this is the RTGC. This is the reflector and the reflector code. So we have a camera here that looks on the code, and from the code, it can determine where he is, which stack he's on, whether he's on the right stack, whether he's in the right position to pick up the container. And that information is pumped through to the RTGC from the operator remotely. In order to, this is a plan view. Here's one runway, here's the other runway, and here's the reflector with the cameras. Now the wheels on this side should be in concert with the wheels on this side. Now sometimes the wheels on this side get ahead or behind, and the RTG tends to want to crab its way down the runways. So in here we have an antenna, and in the concrete pavement we have a transponder that's and the antenna picks up the transponder, which helps it position from the remote side of the camera system, which sets the position of the RTGC. So this system helps prevent it from crabbing and makes it always perpendicular to the runways. The RTGC roadmap, manual RTGC, before diesel powered or electric RTGC, we're now going to electric because of environmental reasons. And with some basic operator assistance technology, things like ladders for him to get up and down. Semi-automated RTGCs, driver-assisted automated functions. Some of the functions were automated positioning. Again, this was brought in maybe 5 years ago. Remote controlled RTGCs, this is where we are now. Automated stacking area operations, supervised automated truck handling, remote manual operations for exceptions. In other words, if something goes wrong, then the remote operator can set it right, can override the automatic system. In the future, we're looking for full automation within the stacking area, unsupervised automatic truck handling. In other words, trucks are automated, they know exactly where to go, remote manual operations for exceptions. So that's where we're in here at the moment on the third one, remote controlled RTGC, and we're moving forward to fully automated. The comparisons, Well, these are essentially the same as the key crane, manual RTGCs, remote controlled in office environment, improves safety and working environment, office fatigue. Again, manually operated, stacking area, remote control, unsupervised automated pickup and landing operations, higher accuracy, faster, safer, no operator intervention. One good thing about automation is it keeps people away from the stacking area. We don't have people wandering around in the stacking area, having to avoid containers swinging around, and operators in the equipment can't see if people are walking around beneath them. They don't have a good overall visual aspect of what's happening around them. Pickup and landing for the internal trucks. Before that was manually controlled by the operator. Now it's automated, faster and reduces operator workload. Similarly for the external trucks, these are operated by the owned and operated. The internal trucks are owned and operated by the container terminal. The external trucks are operated by the consignees. Truck chassis alignment, before manually done by the RTGC operator and truck driver, now automated process using scanning and traffic light technology, similar to the key crane, faster, improved accuracy. Container number checking manually by the RTG operator. We used to have people walking around with clipboards writing down numbers. It's now at the gate. There's automated optical character recognition. The numbers are on the roof of the cab, and there's a reflector on top of the cab. Automatically picks up the number of the container truck and what it needs to pick up. We've got a target detection system this is the spreader, and this is the RTGC, the main beam. The spreader has got to maneuver so it can actually accurately pick up the container. So we've got the target detection system and the spreader detection system. So here we've got it. This is a laser controlled device that picks up where the container is. The spreader detection advice data kicks in here. The target detection system is here, and it modifies it to adjust it to make sure that the spreader can lock on accurately within millimeters to pick up the container. Now, it's the first container that goes down is important because the further, normally we stack 6 high, so the containers that go above it need to be in the right position. We have on the ground, we have these painted crosses, which were essentially a hangover from the manual operation where the RTGC driver would aim to get the corner into the corner here. We've now got these reflectors so that for first landing, we have a laser control device which positions the container so it's extremely accurate. And so we can get 50 millimeters tolerance for a 6 high stack. So it's only 2 inches out of the total stacking height. If you're designing a container terminal using this type of technology, then differential settlement of your foundations is of principal and primary importance. Generally, container terminals are built on reclaimed land, which is subject to settlement and differential settlement. If you're using this type of system, you need to be acutely aware that you cannot tolerate differential settlement. So you need to make sure that when you're doing the construction work, that all the preloading and everything is done properly. Video and broadcasting system, CCTV. If I had shares in a CCTV company before I knew about this, I would have put my money in there. You can see there's bloody thousands of them, CCTVs all over the place. And this means that the operator can get a full view of any direction, any position that he wants. So we have 20 cameras, 3 zooms, 4 spreader cameras. These are on the spreader. 13 hemispherical prime cameras giving a bird's eye view of what's happening. So the operator has plenty of control. Remote benefits of remote control and operation. Here you see before the whole area beneath the spreader was subject to manual control. It had people wandering in and out, and very dangerous because the man in the cab up here can't necessarily see what's happening down below. And occasionally we have personnel squashed by containers being lowered in whilst the guy's eating his sandwiches down in the corner. So increased safety, reduced human error, reduce working load to the operator, it's an automated process, increased productivity, consistent performance. Again, lifting the containers up is done in a standard method. It's not subject to the vagaries of the operator. Reduced wear and tear, that's again due to the smoother operating automated procedure, saves money on cabling. Improved operating working environment. He's in an air-conditioned area, can wear his shorts and his flip-flops, no need to wear special equipment. In the auto zone, the only manual zone is the area where the truck goes for lifting up the containers and putting down the containers. And in fact, the truck drivers are instructed not to leave their cab. They have to stay in the cab. So there's a very small manual zone. What's this one? Remote control and automation. Oh, this is we have scanners to locate the truck and position the truck. Here's the scanners. We have anti-collision equipment to prevent the containers from hitting, once they're being maneuvered, from hitting stationary containers in the stack. This is a view. These views are what the operator sees from his camera position. This is his touch screen information. So very simple, and here's his hand controls. So very simple and easy to, and we have a tannoy system where the operator who's operating the RTGC can speak directly to the truck operator if he needs him to maneuver manually for any reason. We're just introducing a system of traffic lights, traffic indicators in the truck lane. So here's the truck with the container on, and here's the signal which is giving advice to the driver whether he can move forwards, which stack he needs to go, which level he's supposed to be at. So it tells him where the container is and whether he can move forwards. I'm now going to show you an animation. Just on the left here is a smartphone, and the driver has information of where he should go, which stack he needs to go in, and where his container is, which level he's on, which stack. So he's aiming for that. So let's give this a whirl. Off he goes, driving down. He's trying to find his container based on the information that's on his screen. Here's the RTGC. The green arrows are telling the driver he can overtake on the inside or the outside. He can maneuver on either side. Here, now it's flashing, saying, stay where you are. And the arrows here saying, I'm coming for you. I'm coming towards you. On the screen is telling him the RTGC is coming and he's in the right position. So the RTGC has been maneuvered remotely by the operator in the office. And on the other side, you'll see another truck coming along. This truck has got a container on it and it's offloading into the stack. Okay, so the RTGC is going behind the tractor, going onto the trailer and going to pick up. Here you see, here's his container at the back, and he's going to go down, pick it up and put it in the stack. And here's another truck coming in. He's waiting to receive a container from the stack. So the RTGC will move up forwards and load him up. Right, so the screen has said, right, you're okay. Now you can bugger off. And now he's overtaking. This is the overtaking lane, the access lane. These are the high mast lighting towers that we have for illumination at night. So he's going to attempt to maneuver his truck so he doesn't hit our lighting tower, and off he goes. There we go. Oops. Right, I have another short video here. This is from a different view. It shows the truck that we had before. It shows the empty truck. This has just now released his container. Now he's driving off. This is the one we saw before driving off. The RTGC is now maneuvering, so the amber lights flashing and the graphics here telling people or telling the truck drivers where he's going. And this A1026 and the arrow is telling him which stack he's going to, where he's going. Here's the truck with a container. So this is the truck we saw before. We were inside the cab before. He's now coming along. There's another RTGC operating. Remote control. See, before the poor buggers had to climb all these ladders get down to the bottom if they wanted to go for a piss. Now, don't have to do it. So here we go, he stopped. You can go on either side, but you can't get on this side. The spreader is coming down to pick up. Now this is automated until it gets to about here. Then it's manual, picks up the container, lifts it up, puts it in the right position wherever it's going to go. Is inside the cab, his handy phone tells him, right, you're okay, you can go. So now he's clearing off. Now the container is being taken to its designated location, avoiding the terrain of the other containers automatically by using the sensors. Right, okay. This is the last bit now. So won't take much longer. The last part is terminal trucks, manually driven, going to fully autonomous. Normally the manual trucks are operated by LPG or diesel or whatever. Each manual truck is obviously operated by a truck driver. Diesel powered, we get high CO2 emissions. Some electric hybrid models reaching the port industry. We're beginning to get those in now. Manual trucks operate in shifts, therefore impacting seamless productivity. The port operates on a 24/7 basis, and the drivers operate on an 8-hour shift. So when there's a shift change, there's maybe no trucks, or if there's holdups or problems inside the terminal, the trucks can't get to their location. Manually driven trucks more susceptible to human error related. Sometimes the truck drivers, particularly from outside, drive too fast inside the terminal, or they don't have any real experience. When I was working in Egypt, the truck drivers couldn't even read or write Arabic or English. So it made it a bit difficult when they were looking for the containers. Here's a manual truck underneath a yard crane, manual truck underneath quayside crane. So manual truck, quayside crane, manual truck, yard crane. So that's the sequence. Now here's one of our autonomous trucks. This gentleman here is the present director of the Laemchabang Terminal, and he refused to allow me to give the talk unless I showed a photograph of him. So this is him standing in front of one of the trucks that came, I think, in July 2019. Autonomous trucks benefits increased levels of operational accuracy. We've yet to see that. Great levels of predictability. Yes, they're certainly predictable. Increased levels of safety. They go extremely slowly at the moment, so that's all right. Zero emissions, tick, yes. Zero noise pollution, tick, yes, very good. Technologies, radar and LiDAR, object detection, artificial intelligence, yes, that's coming in. Dynamic path planning, routing, yes, that's part of the software that's been used for these trucks. Accurate positioning, that's being developed. Wireless communication systems, I don't know whether that's good or what that technology is. Here you see the cameras. We've got front view, binocular, radar, rear view cameras, LiDAR, trailer view cameras. One problem we had is that the software was picking up the position of the truck. It wasn't picking up the position of the 12-meter trailer behind it. So we had a few end collisions, but that's now sorted out. In a plan view, you can see the area of coverage for the various sensors. GNSS antenna, whatever that is, front view camera, LiDAR, binocular, long-range radar, emergency stop button, that's an essential one. Rear view camera. Many of these things you get on cars these days for automatic parking, for example. We've put in 2 charging points for a test, so each one has 2 chargers on each side. These are the charging the vehicles up. I forget how long they can run. I think they can run on an 8-hour shift, and I think charging is a couple of hours or something like that. I forget the details. Oh, a video. Now this one shows how a car here, when it pulls in front of the automated truck, the truck will automatically stop. Or at least third time lucky anyway. There we go, it's gone in front and the truck automatically stops. Then it starts again. Oh, there we go. Right, and here we have a final video. This is a lifelike mannequin dressed in the livery of the Laemchabang Port Authority with his high-vis jacket and his helmet on. Here's the automated vehicle. So will it stop? He's waving his arms, waving his legs. I don't think it's going to stop. Oh yes, it stopped. So there we go. Excellent. And one development is if we put the mannequin in the uniform of one of our competitors, of course, the truck doesn't stop, just carries on. So that's it, ladies and gentlemen. If you have any questions, I'll be happy to try and answer them for you.
Well, Richard, thank you very much for that. That was a huge amount of information, and yeah, it really gives an idea of what can be done with modern technology in something like a port, where traditionally, I guess, it's always been very manual. So really, really extraordinary. Now we've got time for a few questions. There is one quite long one written in the chat. And if anybody else would like to ask a question to Richard, they can just put their hand up if they raise their hand. I'm not quite sure how I see if anybody's got their hand up, but I'm sure somebody can in the team. So first of all, so are there anybody who'd like to put their hand up and ask a question straight to Richard? There's a very quick reverse run of the presentation going on. There we are.
Oh, sorry. Yeah.
That's all right. No, it's right back to the beginning.
If there are no questions, that's either the talk was very comprehensive or nobody understood what I was talking about.
No, actually, no. Actually, well, we have there's a very detailed question. Now, there are a few coming in here at the moment, but from Andre Pracoso, are you able to look at where it says chat, Richard, at the bottom of the screen? Can you press on chat, and then you will see, rather than me reading it to you, I think it'll be easier if you just look at it direct. It's quite a lengthy, quite an involved question.
Well, do you want me to answer them one by one? What about RTGC housekeeping shuttling moves? Is it automatic?
Yes. Okay. Yes. If you go ahead with that. Yeah. Okay.
Okay. The positioning of the containers, it's not fully automatic. We try and locate the containers which are going to be picked up first. They're going to be top of the stack, and those are going to be picked up later at the bottom of the stack. But sometimes the vagaries of the consignees don't permit us to do that. So it's not fully automatic. It's subject to the vagaries of the consignees. So it's shuffling whilst we try to minimize it as much as we can within the confines of the terminal. It's not, we can't eliminate shuffling. So if that helps with that one.
Right. So if you scroll up a little bit, there's quite a detailed question from Andre, because in fact there are two from him.
Yeah.
Maybe if you can go to the beginning. This was the first main question. So where it says AP, Andre Pracoso, and it starts assuming applying automation implies, and there's quite a long list of things there.
Oh, hang on. Yeah. Oh, sorry. I thought. Where are we?
In the chat function.
Yeah, I'm in the train.
Chat. Yeah, in the chat. If you scroll up.
Assuming applying automation implies.
Yes, that's right. Yeah, that's right. Yeah, that was the first question. Above that, it's okay. We dealt with that. So that's the first major question there.
Yeah. Yes, it is higher capital cost, but it's envisaged that being quicker and more efficient, there will be cost savings. All port operators are commercial animals. They don't do it just for the sake of doing it. So it's envisaged that, yes, there is a high cost of doing this, and we're at the forefront. We're doing testing as well. We're not copying what other successes of other people. We're making our mistakes and trying to resolve them in Laemchabang. But Hutchison feel that the investment is worthwhile in the long term. So and they feel that this is the way to go. But as I mentioned, some governments may not be, or some working environments may not be conducive to implementing automated systems. Australia and the UK, for example, have strong unions, and they may object to having automated systems brought in where they perceive that they're going to lose their jobs. Places like Indonesia, for example, where the government gives the franchise to operate a port for 30 years on the strict understanding that there will be employment for the otherwise employed personnel living around the port. So governments may not enthusiastically embrace these new innovations. Hang on, what have we got? Potential higher maintenance costs due to more expensive equipment. Yeah, I think the idea there is the investment in good quality equipment means that maintenance should be reduced, although this is something that we will take time to determine whether the autonomous trucks have continual breakdowns or whether they go on forever. There's no problem. Only time will tell. Potential lower operating costs due to lower human resources. Yes, in places like Thailand and Indonesia, where the level of payment is fairly low anyway for a driver or an equipment operator. The cost savings are not so great. In places like America, Canada, Europe, where the cost of paying for a truck driver or a heavy equipment operator are high, yes, there will be a saving. So again, it depends where you are. Does the potential increase of performance really did surpass the potential additional provide real financial incentive? We're at a preliminary stage so far. It's only been operational, or it's been being used only for about a year, so it's a bit early to say, and so it's difficult to say, give a percentage how much is it. So long if we're breaking even, in other words, if it's not costing us any more than the manual method in the initial few years, we'd be happy, because we know that in years to come, the automation will prove to be cheaper in the long run. So even if it's no longer, it's even in the short run, if it's the same cost or the same efficiency, then the operator is not too worried. Do you still have tally clerk on the gate or the key? How's the container on the condition? Is it fully automated? The condition, yeah, we do have tally clerks to check the container, any damage to the containers. We have a camera system. I forgot what the hell you call it now. I've mentioned it before. We do have a camera system which can pick this up. So we're phasing out the tally clerks on the gates. Currently, we're trying to have a paperless transaction procedure whereby there's no signatures, no bits of paper transmitting hands. It's all done by swiping a card or being done. The entrance procedures are done prior to the vehicles approaching the terminal gate. So yeah, we're trying to have a paperless transaction and avoid any human interaction at the gate. Seems that RTG is mainly powered by electric and have diesel to move away from their block. What about key cranes? How is it? The key cranes are all electric. They're totally electric. They take a 22 kVA supply. If we have to move a key crane that can't be moved under its own power, if the motor fails, then we need to use a tractor to manually tow it down the rails. So yes, they're all fully electric. What about customs check? Do you have automated container X-ray parts? We don't have an X-ray facility on the terminal, but the Port of Thailand Authority has X-ray facilities. In the port in Jakarta International Container Terminal, they have 2 X-ray facilities operated by customs. Manual stripping, still possible, I assume. Yeah, I think it is, but we don't do it in the terminal here in Thailand. It will be done externally at the Port of Thailand Authority X-ray facility and their customs facility. In the Jakarta International Terminal, the customs are actually on site, and it's done on site. Okay. So I answered the one about, the next one down was, what about RTGC housekeeping shuttling moves? So I answered that one. Usage of autonomous truck, was it only in port container yard area, or would there be other handling from autonomous to common truck house? No, at the moment, it's only controlled within the port area. Autonomous trucks for consignees, I think, is 20 years in the future. We can only control the autonomous trucks and the trafficking within the terminal. The external trucks from the consignees are still manual. Only time will tell when if we get autonomous trucks generally on the public highways. You can raise questions to the speaker.
Oh, sorry, no, that's
let me answer that one.
I don't see any hands up at the moment,
Yeah.
so
Okay.
So keep going. No, so there's
right.
Mohammed Rafi. Yeah.
When changing cargo handling from manual to automatic, do you need to do a complete renovation of the container terminal, or just a change from manual to automatic? As I mentioned, there is a lot of cabling involved. In Laemchabang in Thailand, we're building a new terminal, and therefore we can incorporate all the cabling and everything. If you're trying to do a retrofit, it will cause a large amount of disruption to the terminal operations by digging up roads, putting cables in, and that sort of thing. So it would be a complete renovation if you're wanting to do something, if you're wanting to if you're wanting to change from a completely manual to an automatic system.
I think there's just from our friend Andrea, because there's just one more question right down at the end there.
I don't
a very
understand
short one.
The camera named OCR in your PPT, sir.
I don't know.
In your PowerPoint PPT, is that?
Yeah, that's right. In your slides, you had a camera named OCR. It's not a question.
It's not a question.
Okay, right, there you are. Don't have to worry about that.
Okay.
Well, I think actually, I don't see any hands coming up. I mean,
Mike, there's Alexander's got his hand up, and so,
oh right, okay. Please, can someone?
Alexander Sukerno.
Okay, right. I can't see that, but yes, but yes, please ask away. I don't know what can you. I think you can unmute yourself.
And just as I said that, he's muted himself and put his down.
Actually, I'll ask one little question, which I think you did mention slightly, but I mean, it seems to me that this should generally have a great improvement on safety and accidents and so forth taking place within the handling area of the containers. Is there any firm numbers on that, or is that just assumed to be the case for the time being?
It's assumed to be the case because at the moment, I don't have any statistics. In general, during the year, we have maybe 1 or 2 fatalities due to accidents because we're dealing with 32-ton containers being swung around by heavy equipment, and people get in the way. The good thing about automation is on the slide that I showed you, the area beneath the RTGCs, which was fully accessible by any of the Port Authority staff roaming around, any of the terminal staff roaming around, is now excluded. So personnel are not permitted within the stacking areas unless they have a particular reason, and they have to notify the security of where they're going and why they're going to this particular location. We have fencing inside to prevent people from getting within the stacking areas. But I'm sorry, Mike, I don't have any statistics to give you. We don't have, sort of 40 or 50 fatalities a year, and we're now down to 20. It's only something like 2 or 3 per year if we're unlucky. And as far as I know, just in general, the security and safety procedures, at least at Laemchabang, have been improving year on year. So whether it's due to automation or whether it's just due to an increased level of supervision, I'm not clear. I can't really answer that one.
Okay, well, just one. We have, I think, probably the last question from David Mee has his hand up. David, you want to ask your question? I think you'll have to unmute yourself.
I thought, am I not unmuted?
No, you are. No, we can hear you. Keep going. Yes.
Okay, good. Yeah, Richard. Yeah, we haven't seen you around here for quite a while, so I was just wondering if you could let us know what's been your role in all this. rather a
Well,
different type of question, right?
Yeah. Well, I was in 2019. I came out to Laemchabang working with Hutchison, as Hutchison are the investor, the employer, and I came out as a site project manager, but acting on behalf of the client rather than a consultant. So my job was to ensure that the client got value for money and we got the job built within specification, the quality was good, and we, more importantly, got it finished within budget. Now, I've been involved, our head office down in Hong Kong has been wanting to use Thailand, the port in Laemchabang, as a test field, if you like, for testing some of this high-tech equipment and these new technologies. So I've been involved in liaising with the guys down in Hong Kong and the subconsultants, who are generally Chinese subconsultants, who are providing the automated trucks and providing the ZPMC, who are the providers of the key cranes, and the RTGCs are also providing the automated systems. Now, one thing I might point out is if you have a supplier like ZPMC, which is a mainland Chinese supplier, or if you have any other supplier of equipment, and they also are running their own research and development on automation, if you sign up a contract with them, then your automated system only works with their equipment. So your hands are tied in years to come. If you want to buy, if their key cranes suddenly become 20% more expensive and they're automated, it's very difficult to change to another supplier, because the automated system of your alternative supplier is likely to be incompatible with the automated system of your current supplier. So you have to be very careful about getting automation in your equipment, because in a way you can tie yourself to that particular supplier for the rest of the life of the terminal. So that's why they fired me.
Oh, no. Okay, well, that's I see no more hands up. Okay, some thanks there. Thank you very much. I think probably now, Richard, you've been talking to us for quite some time now. You've covered a huge amount of information there and dealt with a lot of questions. So I'd like to thank you very much indeed for doing that and stepping up to give us this talk, which has really been fascinating, because I think it's a topic probably we suspected was going on, but to actually see how these things work is really interesting, especially with some of those animations which you must have spent hours creating. I don't know how you do a thing like that.
Oh hell, I.
But no, well, thanks, Richard. Thank you very much, and certainly on behalf of the organisers, I'd like to thank you. But I'll give you your chance to rest now. I will hand back to our MC Ryan, who will then also hand over to Phil to bring the event to a close. So Richard, personally, again, from me, thanks very, very much, and shall be in touch in the near future. Bye then.
Thank you.
Yeah,
much appreciated. Thank you so much.
Thank you, Richard Green, for your speech, and Michael Dobie for being our moderator for today's webinar. Now, I would like to invite the chairman of ICE Jakarta Local Association, Phil Woodmansey, to give his closing remarks. To Phil Woodmansey, the time is yours.
Thanks, Richard. Thanks for taking the time to talk to us. Thanks to everybody for joining as well this evening. I realise that there's a commercial side to what Hutchisons are doing, but it's fantastic to see that the innovations are, built around ergonomics and working safely, which is obviously really high priority in an industry like this. So it's really good initiative, and I hope it's successful. I was wondering is it easy to retrofit existing ports automated, or is it better if you have a new port? But I'm not sure about that one. Maybe you can answer it another time. But anyway, I think we better bring the evening to a close. Thank you everyone for joining us, especially to you, Richard, and have a good night, everybody. Thank you.
Yeah.
Thank you.
Yep. Thanks, Richard. Thanks, Phil.
Yep. Cheers.
Thank you, Phil Woodmansey, for your kind remarks. Once again, thank you, Richard Green, for your excellent presentation. And thank you also to Michael Dobie for guiding the session. Ladies and gentlemen, we have now reached the end of the event. Once again, thank you for your participation. We hope we can see you at the next event. At last, good evening and stay healthy, everyone.